as I said, we're going to go ahead and start with algebra. And there's various parts of algebra we're going to have to be able to be comfortable with in order to succeed in physics. And the first is the most basic of all of algebra, which is I give you an equation with an unknown variable in it, and you have to tell me the answer. What is the value of that unknown variable? So, for instance, 3x plus 4 equals 34. Now, we all learned how to do this in algebra in high school. And what the algebra teacher would tell you is, in order to solve this, you have to get x by itself. And to get x by itself, you have to do things in a certain order. So, for instance, you have a 3 on the left and a 4 on the left. And you want those away. You want x by itself. But you can't just pick one of them to move first. You have to do it in a certain order. And the order is, the way to think about the order goes like this. What does this actually tell you? This says there's some function f, okay? Function just means you're going to give me a number, I'm going to do a bunch of stuff to the number, and I'll give you an answer. That's what a function is. This function says, you give me x, some number. I'm going to multiply that number by 3, and then I'm going to add 4 to it. And when I do that, I get the answer 34. Okay? That's what this is saying. So if you want to say, what number must I have given him in order for him to get the answer 34? So it's a number that you multiply by 3, and then you add 4 to that thing, and you get 34. Well, the way to handle it, if you think about it, is, well, if I multiplied by 3, then added 4, well, the first thing I have to do is take away the 4 to get back. So I take away the 4 first, and then what's left is the number that I multiplied 3 times that number. So how do I get rid of doing multiply by 3? I divide by 3. That inverses, that cancels out doing that operation. So if you think about it in that sense, what this tells me is the order I have to do is all of the adding stuff, adding or subtracting, then all the multiplying and dividing. So the algebra teacher would say, okay, to get rid of this plus 4, which is the first step, I do minus 4. And so if I subtract 4 on the left, that cancels the adding of 4. But whatever I do on the left, I have to do on the right, so I also have to subtract 4 on the right side. And what's left over? 3x is still on the left, and now the right side has 30. Again, I don't have the answer yet. I still have something happening to my x, so I need to get rid of it. How do I do it? Well, right now I'm multiplying. To do the opposite, to cancel it, I divide. If I divide the left side by 3, that cancels the 3's. But whatever I do on the left, I have to do on the right, so I divide the right side. So I get x is 30 over 3, which is 10. That's what algebra says. And it's true. That's exactly right. But what I'm going to tell you is if you think about it this way, and you write it down this way, you're doing a very inefficient way of doing it. You're doing a lot more work than you have to, and you're thinking about it in a more complicated way than I think about it. So let me show you what I do. What I think about, and it becomes more evident later when we have fewer numbers and more just variables everywhere. But if I look at this problem, I basically think a lot of the same stuff. I want to get x by itself. Well, the first thing I have to do is get rid of the 4, because I'm leaving x there, so I'm not going to move x stuff. So the 4 is the first thing I can move. Now, I'm not thinking about canceling the 4. In my brain, what I'm thinking about is, here's this thing, I want to move it to the other side of the equation. Just move it over there. And the rule is when you move a term to the other side, it changes sign. So, for me, I say, all right, move the 4 over, and what's left? 3x is still on the left. And now on the right side, what do I have? 34, and now I have a minus 4 over there, because plus 4 became minus 4 when it moved. So that's just 3x is equal to 30. And now the same thing here. Again, x is not by itself. I need to keep x alone and move everything else over. How do I move the 3? Well, right now the 3 is on top. To move it to the other side, it has to go to the bottom. So I say move the 3 over. So x is 30 over 3, which is 10. Now, we're doing exactly the same thing on the left side versus the right side here in terms of the work. The difference is how you're visualizing what you're doing. This is going to be important when I give you an actual physics equation and almost everything is just variables and there's no numbers. It's a lot easier to visualize moving terms from one side of the equation to the other rather than trying to think about subtracting off this amount, we'll cancel that, and then I have to do the same to the other side and that kind of stuff. So, my hint to you is to start getting into that mindset, if you're not already, of thinking about moving terms in an equation rather than solving the equation using the rules of algebra. You're moving things around to get a term by itself. That's all you're doing. So this is a basic one, right? There's one way to do it. Move the terms without the x, then move the stuff that's on the x, and then you have x by itself. But there's going to be more complicated equations. For instance, one of them will look like this. What if instead we have an equation, x minus 6 is equal to 43? I want to solve this. Now, first thing I see is this is not a normal algebraic equation anymore. This is what's called quadratic. And it's quadratic because the exponent sitting on my variable is bigger than 1. This tells me a few things. First thing it tells me is I'm going to need 2 answers. And that's a general rule. Given an equation, the variable you're looking for, the highest power that variable has, that's how many answers you better give me. So in this case, it's x squared, so I'm going to give you 2 answers. But to solve it, we're going to basically do the same thing. I want to get x by itself. Always do that. So I want to bring the minus 6 over to the other side, or bring the 6 over to the other side. So it becomes plus 6 over there, so I have x squared equals 49. And now the only thing we have to know to solve this is, well, I want x, but I have x squared. How do I get rid of the x squared? To get rid of an x squared, I take a square root, obviously. And so I have to do it over here too. And so the square root cancels the square, and we get x on the left equals 7 on the right. But if you notice, this is only one answer. And I told you, if the highest power on your variable is 2, you need 2 answers. Well, the second answer comes from the fact that this isn't actually correct. What's really correct is when you take the square root, there's this plus or minus out in front. Now, I always hated this when I was in high school. I'd always forget the plus or minus. I'd always give the positive answer. But in reality, especially in physics, the positive answer and the negative answer are 2 completely different things. For instance, say I give you a physics problem. I throw a rock into the air under gravity, and I say, after 3 seconds, how fast is the rock moving? And this is the answer I get. Well, if I do this, the answer is either plus 7 or minus 7. Plus or minus. And it matters which it is, because if it's plus 7, that means it's rising with a speed of 7 meters per second. If it's negative 7, that means it's falling with a speed of 7 meters per second. And if you're doing this to predict, or you're doing this because you need to do something specific, you need to know, is the rock moving upwards or is it moving downwards? Because that's going to change a bunch of things. So you need this plus or minus there, because sometimes the answer will be negative 7. Because maybe you threw the rock downwards, or it fell off a cliff or something. So it's moving down. But in the end, this is how you handle this type of problem. Not so bad. You handle it the same way you handle regular algebra, except at the end you have to take a square root. Pretty good. Of course, it gets more complicated. What if we have something like this? Let's say we have x squared minus 4x minus 1 equals 4. So this is an equation. X maybe tells me how far something went. And I want to be able to solve this. How do I solve a problem like this? Well, first thing to know is that, again, this is quadratic, because the highest power on my variable is 2. So first thing I know, 2 answers are going to come. Second thing I know is it's not going to be as easy as just regular algebra. How do I know that? I know that because I've got 3 different terms. I've got the quadratic term, the square, the linear term, the term which is x to the first power, and then I've got this coefficient, a number. Here's another number, but I'm going to be moving that eventually, so it's part of the number. It's just a number. When I see this, I know first thing to do is put this in what's called standard form. Standard form is ax squared plus bx plus c equals 0. That's what I want my equation to look like. So if it doesn't already look like that, I got to make it look like that. So these are close, except this 4 on the right side of the equation needs to be a 0. So first thing I'm going to do is move the 4 over to the left. So now my equation is x squared minus 4x, and I'll have minus 1 minus 4 becomes minus 5. All right. And then equals 0 is still on the right. Okay, now what? If you were in high school algebra, the algebra teacher would tell you, factor. You want to find 2 binomials, blah, 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 equals 0. One has an x, one's plus, one's minus, and so that kind of stuff. Don't do that. This is not math class. And I promise you, even though it might work with this particular example I wrote, in physics, the numbers won't be this neat. There's going to be decimals all over the place. So you'll never be able to actually factor it. So, don't factor. We're going to have to do the brute force method. And the brute force method just says quadratic equation. The quadratic formula, I should say. Quadratic formula. What does it say? It says if you have an equation that's in standard form like this, the answer is x will be equal to minus b plus or minus square root of b squared minus 4 times a times c, all divided by 2a. So, given you know the value of a, the value of b, and the value of c, you plug the numbers into this formula, you simplify, you put it in your calculator, whatever you do, and you'll get an answer. In fact, you'll get 2 answers. And you'll get 2 answers because of this plus or minus sitting here. One if you use the plus, and another different answer if you use the minus. And that's all there is to it. This always works. If you're given a quadratic equation, sometimes you can factor, And if you can factor, it's easier. It's less time consuming. But if you can't factor, then you have to use quadratic formula. And the good news is, even if you can factor, you can use quadratic formula. And so if you're like me, I'm, number one, lazy, and number two, I don't have a good memory. So I tried to find ways of solving problems where I learn one thing, and that thing can be used for multiple different problems. I'd rather that than learn 3 different shortcuts. One shortcut works for this, one shortcut works for this, and one shortcut works for that. Because now I got to remember 3 different things, and I have to remember when to use which one. I don't like that. So when I see a quadratic equation, I'm always using quadratic formula, whether I can factor or not, because it will always work. So I just remember one thing to do. So let's do it. Here we have our, here's our equation. That's the thing I want to solve. So first thing I'm going to do, just to make it easy, to make it look nice, is I'm going to write down what is A, what is B, and what is C. So A is the number, the coefficient in front of the x squared. So in this case, the coefficient in front of the x squared is 1. Just a 1 sitting there. B, that's the coefficient that's in front of the linear, the x. So for me, it's this term here, and that includes a negative. So it's minus 4. And in C, that's just the number that's not in front of an x. And so for this one, it's minus 5. So you have to include the pluses and the minuses here. All right, so there we go. I now know what A is, I know what B is, and I know what C is. Now the rest is purely plugging it into the equation or the formula to get my answer. So let's do it. X equals minus B. Well, B is negative 4, so it's minus negative 4 plus or minus the square root of B squared, negative 4 squared, minus 4 times A is 1, times C is negative 5. All of that is divided by 2 times A, which is 1. So now I've plugged all my numbers in. All that's left is to simplify it down to a number, or 2 numbers. So how do I do it? Well, let's see. On the outside, negative 4 is positive 4, plus or minus square root of. Negative 4 squared is 16, minus 4 times 1 is 4, and 4 times negative 5 is negative 20, divided by 2. Okay? And then that is 4 plus or minus square root of. 16 minus negative 20 is 36, divided by 2. And now I see how I get my 2 answers. The top row here will be the positive. Let's see. It stopped capturing me. Let me stop and share again because it stopped following what I was doing. We have 4 plus square root of 36 over 2 and 4 minus square root of 36 over 2. Square root of 36 is just 6. So we have 4 plus 6 divided by 2 and 4 minus 6 divided by 2. 4 plus 6 is 10. 10 divided by 2 is 5. So the first answer is 5. And down here, 4 minus 6 is negative 2. Negative 2 over 2 is negative 1. So the other answer is negative 1. And there we go. I got my 2 answers. X can either be 5 or it can be negative 1. And that's how you solve quadratic formula or quadratic equations. This will come up sometimes, so you have to know how to use quadratic formula, especially in kinematics. it'll pop up. But once you know quadratic formula, it's just a matter of plugging the numbers in, and then just use your calculator to help you with the square roots and stuff like that. Now note that you might have something that kind of looks quadratic but isn't. So you might have something like this. 4x squared plus 8x equals 0. So it's quadratic in a way because there's an x squared term, but it's not the quadratic equation. And the reason is because, yes, it's got the squared, yes, it's got x to the first, but it does not have the number, the c. And so because of that, we don't have to use quadratic formula, which is always nice. I'd rather not use it if I don't have to. So if I don't have to use it, how do I solve this problem? Well, this is what I do. This is how I think. Here we're going to factor. We're going to do the easy factor, though, not the other factor. This factor is find out what's in common with all the terms. So when I look at this, I see, well, there's an x here, and there's an x squared over here, so I could take one of those x's, and so both terms have 1x. Also, this term over here has a 4, and this 8 is a 4 times 2. So I could take his 4 as well. So both terms have a 4 on it. So now I know every term in my equation has a 4 and an x. So what do? I rewrite it by taking that 4x outside, and then I just have to write what's left over. So on the first term, if I have 4x already, the only thing not there is the extra x. And in the second term, what's sitting there? Well, I already used the 4, I already used the x, so all that's left is the 2. So 2. And that equals 0. And then just to confirm, make sure we did it right, 4x times x is 4x squared, and 4x times 2 is 8x. So yeah, it's the same thing. So I just factored everything that's in common outside. Now notice, you didn't have to factor it that way. You could have just taken out an x. You could have just said x times 4x plus 8 is equal to 0. That's also true. And that's perfectly fine if you want to do it that way. But I try to take out everything in common if I can. All right, now the answer is, how do I solve this thing? Is this any easier to solve than the other thing I had before I wrote this? And the answer is yes, if you understand what it means. So to show that, forget this and look at this problem. Can anybody tell me if you have some number a times some number b equal to 0, what does that tell you about a and b? Anybody know? If a times b gives you 0, what does it tell you about a and b?
1 is 0.
One of them, at least one of them, has to be 0. Obviously, if you have two numbers and you get 0, it can't be 2 times 3. It could be 2 times 0, or 0 times 2, or 0 times 0. So, this is easy to see that. But this problem is identical. Notice, here's one number. That's one number sitting there. This parentheses is some other number. So in reality, this blue equation I wrote is some a, called 4x, and some b, called x plus 2, equal to 0. And so that tells me either 4x is equal to 0, in which case x is 0, or x plus 2 is equal to 0, in which case x is negative 2. And there we got our answers. So if you're given a problem like this, you factor it out, and as long as you understand what this is saying, either 4x is equal to 0 or the other term, x plus 2 is equal to 0, and you solve those two things independently, then things go smoothly. Notice the green one I wrote here, in case you did it this way, same thing holds. This tells you either x is equal to 0, or this term, 4x plus 8 is equal to 0. And so that says 4x is equal to negative 8. X is equal to negative 8 over 4, which is negative 2. Same answers. Of course it's the same answer. It better be, or we've broken mathematics. So that's how you handle this type of equation. It pops up sometimes, especially if we're doing like a kinematics problem where you shot a cannon and it's symmetric. So where it lands, the height where it lands is the same height as where it started. Then some of the terms drop out of the equation, which you'll see. And so instead of a quadratic formula, you'll have a formula like this, which is a lot easier to solve. All right, last thing about algebra. And this is what happens when you're working a problem and you're looking for two answers. Let's say I threw a rock off a cliff with a certain speed, and I want to know, firstly, how long does it take to hit the ground? And then I also want to know how far away from the cliff will it land. So I want to know a distance and I want to know a time. Well, what if I can't find a single equation that'll give me x or that'll give me t? What if every equation I have has both x and t in it? So I can't separate them. If I want to solve x, I need to know t. And if I need to solve t, I need to know x. How do I handle something like that? Turns out this is what's called either simultaneous equations or systems of equations. And what I mean by that is two equations with two unknowns, or three equations with three unknowns, things like that. So for example, let's say we have an equation, minus 5x plus y is negative 2, and minus 3x plus 6y is negative 12. So let's say x is the distance, y is the time. Notice I can't use either one of these equations to get one of the variables. If I tried to use the first one to solve for x, there's still a y sitting there. And if I try to use the second equation, again, there's still a y sitting there. So how can I get just x by itself, or just y by itself? Well, it turns out there's many ways of doing this. And if you remember in your algebra class, you may see the teacher do it different ways. I'm going to use a particular method that I found to be the method that takes the least amount of thinking. You basically just do a step, solve the equation, it gives you something, do another step, and you don't have to be creative. And this method is what's called substitution. The substitution method goes like this. Given two equations with two unknowns, let's say. Choose one of the equations. Which one you choose is up to you. It doesn't matter. You can choose the first or the second. Choose one of them and solve that equation for one of the unknown variables. Now what you're going to get is not an answer, but it's going to be something like x equals blah, 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 y. So you'll still have the second variable there, but at least you've solved for x. So do that first. So for me, what I'm going to do is I'm going to solve the first equation for y, because that's the easiest one. So I'm going to choose the first equation to solve for y because it's the easiest. Notice y is by itself with no number in front of it. So I'm choosing, take the first equation, minus 5x plus y equals minus 2. Solve for y. How do I solve for y? I move the 5x over. So y equals negative 2, and now the 5x becomes positive 5x because it changes sign when it moves. So there we go. I've done the first step. Choose one equation, solve for one of the variables. Done. What does this tell me? This tells me if you were to tell me the number for x, I can give you the answer for y. But I don't know x yet, so I have to keep going. But at least if I knew x, I'd have an answer. All right, the next step of substitution is where the name comes from. Now that you know something about y, one of the unknowns, substitute it in for the other equation, or into the other equation. So I just used the first equation. I can't reuse it. I have to go to the other guy. So now wherever I see a y, instead of plugging in y, I plug in this thing. What happens if I do that? Well, I get minus 3x plus 6 times, instead of saying y, I say minus 2 plus 5x. Okay? And then I just finish equals negative 12. How did this help me? That's something that you should have in your mind. Why did I just do this? What the heck was the point? It just got bigger. Yes, it got bigger. However, notice there's only one variable in this equation now. Y has disappeared. Now we have an equation with only x's. And everyone knows, one equation with one unknown, you can solve it. So good, I'm about to get an answer. So let's do it. I'm going to solve this for x. All right, so minus 3x is still sitting there. Now what do I have? 6 times negative 2. Well, instead of negative 2, 6 times negative 2, I'm multiply it, I'm sorry. I don't like this plus. It's going to be a minus 12. And then 6 times 5x, remember I'm distributing to both terms. 6 times 5x is plus 30x. And that equals negative 12 on the right. Okay, now I'm going to collect like terms. So all the x's on one side, all the other stuff on the other. So minus 3x plus 30x is 27x. And then the negative 12 that's on the left, I'm going to move it over to the right. And so negative 12 plus 12 becomes 0. And this is easy. Solve this for x, I get x is equal to 0. I now have one of my answers. I now know x is 0. However, I still need to find y. How do I do it? I do one more substitution. Remember I said right here that if you were to tell me what x is, I could tell you what y is. Here's our chance. Get this x, plug it in right there to get y. So y is negative 2 plus 5 times the value of x, and x is 0. So y is negative 2. And we've now solved the problem. And this is how I do it every single time. To me, it doesn't take any thinking. As long as I'm following the rules of algebra, and negative signs are fine and all of that, I just follow it. I just crank it out like a machine. The other way you'll see people doing this, especially if they're math professors, is they'll do it slightly different. Let me just rewrite it and show you what I mean. Minus 5x plus y is negative 2, and negative 3x plus 6y is equal to negative 12. So what a math guy might do is he'd say, aha, I'm going to manipulate the equations to get rid of one of the variables. And so, for instance, I might say, if I were to multiply this equation by negative 6, then I would get 30x minus 6y is equal to 12 for that top equation. Multiplied everything by negative 6. What's on the bottom, the other equation, I didn't do anything, so it's still minus 3x plus 6y equals negative 12. And then the professor would say, add these two equations together. And if you do that, 30x minus 3x gives you 27x. The negative 6y and the positive 6y cancels. And the right side, 12 minus 12, gives you 0. And so we get x is equal to 0. And then once we have that, we take that x and substitute it in somewhere. That works. It's perfectly legitimate. However, I don't like having to think at the beginning, what should I multiply this thing by to be able to add everything together for things to cancel out. If you like doing it that way, that's fine, because it's real. It's a real method. But for me, this takes a lot less thought. I just do algebra. I solve for a variable. Once I have it, plug it into the other equation, solve for a variable. I don't have to think about things. I don't have to be creative. I just crank it out, kind of a thing. However, I will not mandate one method or another. I'm just telling you, when you see me solve systems of equations in this class, you're going to see me do it this way. So that's systems of equations. And this will come up sometimes, as I said, when we're doing collisions and things like that, you're going to see it. The last thing I wanted to show was talking about the whole moving things around. So I don't think I did this yet. Yeah. When I talk about algebra is, don't think about it as adding on this side cancels and so you got to add to the other, but rather moving terms. Here's what I mean. Here's, spoiler alert, an equation you're going to get in kinematics in a week or two. X equals v naught t plus 1/2 a t squared. So here's one of the equations we're going to use in kinematics, and it's a relationship. It tells us how far an object will go given its initial velocity is something, it moves for a certain period of time, and there's a certain acceleration. Maybe it's speeding up or slowing down or staying constant speed, whatever. So it relates all these variables together to be able to determine what will happen. Okay, but here's the thing. I have this equation, but let's say I don't care about how far it goes. Maybe I know how far it goes. And what it is I'm trying to find is, what's the velocity? How fast did it start for it to have moved this far? What that's basically asking me to do is solve this equation for v naught. Now, the last thing I want to do is memorize another equation that says v naught equals blah, blah, blah. If I have to memorize something, I want to memorize one thing and then do work to get all the other ones so I don't have to think about it. So how would I solve this equation for v naught? Well, it's just algebra. First thing I do is I want v naught by itself. Okay? So I'm going to leave the v naught stuff there. Everything that's not on v naught, I move to the other side. So here's something. It's 3 different numbers, but we don't think of it as 3 different numbers. It's just a thing. I'm going to move this term over to the other side. And again, when you move it to the other side, it changes sign. So now I have x minus this new thing, 1/2 at squared. And then on the right, I still have my v naught and t. And now again, I want v naught by itself, but there's a t sitting there. I don't want the t on the right side, so I move it over to the left. It's on top, so it moves to the bottom. So I have x minus 1/2 at squared. Now I'm dividing by t is v naught. And so for me, so this is some new equation. This is the equation that tells you, given you know this other stuff, what's the initial velocity. But it's really the first equation written in a new way. But what I want you to see from this is, when you don't have the numbers, it's a lot easier to think of the algebra as moving terms to either side, rather than, all right, I'm adding a half, I'm adding an a, or I'm subtracting an a over, cancel the a's, none of that stuff. You want to get in the habit or be comfortable enough that you really think about it as, here's a piece, and I'm just moving the piece over here. Okay? Because this is the kind of thing you're going to be doing. You're going to be given two different equations, but there may be four different variables you have to be able to solve for. So you have to be able to take one of the equations you already have and manipulate it to get one of the other variables. And that's what the algebra is all about. But anyway, that's all I want to say about algebra today, unless